When design professionals need to renovate existing facilities, more and more often they turn to laser scanning to quickly capture existing conditions. You can link point cloud data from 3D laser scanners into Revit for use in creating building model objects. To link a point cloud file, on the Insert ribbon, in the Link panel, click Point Cloud. Revit displays the Link Point Cloud dialog. I'll navigate to the folder containing the exercise files. In the Files of Type drop-down, you can choose to select from Point Cloud Projects, Point Clouds, Raw Formats, or All Files. As you can see, Point Cloud Projects have an RCP file extension, while Point Clouds have an RCS file extension. When you select Raw Formats, there are several file types that you can choose from. If you are not sure what kind of file your point cloud is, you can select All Files. These file formats represent the most popular formats and account for the majority of scanning devices. I'll select Raw Formats and then choose lobbyscan_ascii.pts. When I click Open, Revit displays a dialog informing me that the point cloud file is not an indexed file, and asks if I want to create a new index file. The dialog warns that this may take some time. Revit can only link indexed point cloud files, but as you can see, if you don't already have an indexed file, Revit will create one for you. I'll click No, and then click the Point Cloud tool again. This time, I'll select the lobbyscan.rcp file. Pay attention to the positioning options. I'll leave this set to Auto, Center to Center, and then click Open. It takes just a few seconds to link an indexed point cloud. I'll open the default 3D view and then orbit around a bit so that you can get a better look at the point cloud. When I select the point cloud, in the Properties palette, you can see the name of the point cloud file. I'll click Edit Type to display the Type Properties dialog. Here, you can see a scale value. I'll click Cancel to close the dialog. I'll switch to the South Elevation view. The point cloud is located below the lowest level. With the point cloud selected, on the contextual ribbon, in the Modify panel, I'll click Move. Now I can see a bounding box around the point cloud. I'll zoom in and move the cursor over the left side of the bounding box near the bottom. Revit will snap an alignment plane at the base of the object. I'll click to establish a start point, and then move the point cloud vertically, and then click to align it with the level. I'll zoom in a bit more so that I can see the stair landing at the next level. I'll select the level and then move it until it snaps into alignment with the stair landing in the point cloud. You may have to zoom in a bit closer and repeat this to get it to snap into alignment with the landing. Then I'll zoom back out. The distance between level 1 and level 2 should be approximately 15 feet, or 4,600 millimeters in the metric file. You may have to adjust these levels a bit more later to get them precisely positioned, but right now, working by eye is close enough. I'll switch back to the level 1 floor plan view and select the point cloud. On the contextual ribbon, in the Modify panel, I'll click Rotate. On the Options bar, I'll click Place. Then, I'll zoom in to the lower right area of the point cloud. When I move the cursor over the points representing the wall to the right of the furniture grouping, Revit picks up an alignment plane on the left side of the wall face. I'll click to establish the center of rotation. Then, I'll click to align the starting direction along this wall, and then right-click. I'll choose Zoom to Fit, and then move the cursor so that Revit snaps to vertical, and then click to pick the second alignment point and rotate the point cloud. The point cloud is now aligned to Project North. Now I can use the point cloud as the basis for creating walls. From the Architecture ribbon, in the Build panel, I'll start the Wall tool. In the Type selector, I'll choose Generic 8-inch or Generic 200mm in the metric file. I'll zoom in on the point cloud. To use the same wall face that I just used for the rotation, on the Options bar, I'll set the location line to Core Face Interior. Then, I'll move the cursor over the point cloud to find the alignment plane representing the wall. I'll click to pick the starting point of the wall, and then move the cursor down approximately 7 feet 4 inches, or 2,200 millimeters, and then click to pick the ending point of the wall. Then, I'll press the Escape key one time to end that wall. In the Type selector, I'll choose the Curtain Wall Storefront. I'll start a new wall to the left of the previous wall and follow the point cloud to create a curtain wall approximately 2 feet 6 inches, or 800 millimeters long. I'll zoom out a bit and continue to work my way around the point cloud. Pay attention to how Revit locates alignment planes in the point cloud. As you place walls, more snap planes become available. This is a manual process. You're simply tracing the point cloud. You can use field measurements to help refine the accuracy of your model. Now that I've created a number of walls, I'll click Modify to end the command. I'll go back to the south elevation view to check my work. Then, I'll switch to the 3D view and orbit around a bit to compare the walls I've created to the point cloud. I'll switch back to the Level 1 floor plan view. On the Quick Access toolbar, I'll click Section. I'll draw a section line from top to bottom through the stair landing that I can see in the point cloud. I'll adjust the far clip control on the right so that it stops short of the vertical wall I created. Then, I'll right-click and choose Go to View to open the new section view. In the section view, I can further examine the wall placement compared to the point cloud and make adjustments as needed.